Let's review the Genesis objects we've studied so far. Both the transaction object and the web panel object provide a runtime screen that allows the user to interact. Both performing CRUD operations, create, read, update, delete, on the database in the case of the transaction, and querying data, applying filters, and performing actions in the case of the web panel. In both cases, then, the user interface is modeled, and the code that governs behavior is specified in the same object. This code is both procedural, that is, commands executed sequentially from first to last, as in code written for events, and declarative, as in rules where the order generally does not matter, with some exceptions. We also studied the data provider object, which allows returning both simple structured data and collections of data loaded into memory. It has no user interface, it is batch. And it doesn't allow us to update the database, only to query it at most. That's why we placed it in this box. The way to load these SDTs or SDT collections is through declarative coding. But we could achieve exactly the same result using procedural coding, like the one we use in web panel events, by means of another object, the procedure. This object can receive and return information, and its main characteristic is that it includes procedural and batch coding. So, this object not only lets us do what a data provider does procedurally, but much more, because its scope is much broader. It can query the database and return not just an SDT or a collection, but anything. It can also update the database using certain commands. In addition, it will not only allow batch manipulation of the database and performing queries, but it will also be able to generate PDF reports with the collected information. Export data by generating Excel, XML, JSON, etc. files. Import data by reading external files. Write or generate server-side files. Integrate with external services. Consume or publish APIs. Send HTTP requests. Send emails. Perform complex calculations, and much more. In this video, we will see an example of a procedure used as a function, where it will need to query the database to perform a simple, non-complex calculation. In the previous video, from an SDT named AttractionInfo, we had declared a data provider that returned a loaded collection of that data type, filtering the attraction entity to include only tourist attractions in Paris. This is what it returned, based on the data we had in the database. These two attractions in Paris, and this one in Beijing. For each item in the collection to be returned, each member of the item was assigned an attribute, except for the last one, which we assigned 0, because we didn't have an attribute to record it. Now, we are going to calculate that value dynamically for each attraction. That is, for each record in the attraction entity that meets this filter. How would this calculation be done? We can think of it as a function, so that for each attraction that meets the filter, with these data, Paris is identified by the pair 2,1. This first attraction, the Louvre Museum, meets the filter. Then, an item will be created for it. The value we need to calculate corresponds to the number of flights arriving in its city. So we need to take its city, which will be the same due to the filter, in order to retrieve all flights arriving at airports in that city. With this data, it will be only this one. These will be the flights retrieved. So, for attraction 1, if we count them, the count will be 3. And that result from the function will be assigned to the flight's arrivals member. And so the first item in the collection built by the data provider will look like this. The collection will have only one more item, attraction 3, which meets the filter. Then, to calculate the id, name, country, and city members of that item. It takes the values of the attributes directly. Some are in the base table record itself, such as attraction id and attraction name, and others are in tables of the extended one, such as country name, which we haven't shown here, and city name. But for flights arrivals, it will have to run that function, which we'll implement as a procedure object. We'll have to pass it a parameter corresponding to the ID of the attraction for which we want to obtain the number of incoming flights to its city. So we'll invoke it by passing the attraction id attribute. The procedure will perform the calculation as we saw before, which in this case will give the same result, 3, because the city is the same, Paris. Then we'll have to create a procedure in our KB and name it accordingly to indicate that it will calculate the number of flight arrivals. This object must receive from the caller the identifier of a tourist attraction. To do so, it must declare an input variable, which will be loaded when the procedure begins execution with the value sent by the calling object. Then, if we place the invocation getFlightsArrivals here, passing as a parameter, in parentheses, the value that the attraction id attribute has at that moment. For the first iteration of the group, the attribute will have the value 1. Then 1 will be sent to the procedure, which will initialize the variable with that value. And there it will start its execution. When finished, the procedure must return to the caller a number, which will be calculated inside the procedure. We must then declare the variable that will register that result. That variable will start out empty and it will be within the procedure source among all its code where it will be loaded. The value that the procedure will return to the one who invoked it will be the value that the variable holds at the end of the execution of all the source code once the end is reached. Therefore, it will be necessary to define these two variables in the procedure. But in addition, it will be necessary to indicate that they will be parameters to communicate this object with the one who invokes it. Let's ask the assistant to initialize a getFlightsArrivals procedure for us that receives an attraction ID and returns the variable antFlightsQti. At this moment, it is asking its agent specialized in each task to resolve the request. We wait. Well, it has now replied, having created the procedure. We see that within it, it created the two variables. For attraction id, it didn't choose the data type correctly, but it doesn't matter, we change it. Note that we have the classic source tab and left us this comment here. It is here that we will have to write the commands to assign a value to flight's quantity, which will be the output variable, because if we look at the rules section, we see this statement. This is the PARM rule, which specifies the parameters that this object will exchange with those who invoke it. Note that this is an ordered list of parameters. The in and out modifiers are optional, but using them provides clarity and avoids problems. There is also in-out, which is used when you want to indicate that a parameter will be both input and output. This PARM rule is fundamental because it is universal. It is the rule that will be used in any object, not only procedure, that can be invoked by another, to declare the interaction parameters. Of course, we could have created this procedure object ourselves with new object. Choosing procedure. Now that we have defined this object's communication parameters, Even before writing its code, we can save the object and go to our getAttractionsList data provider to assign to this member of the items loaded from the database information the result of invoking the procedure we just created. We can see that as we start typing its name, it already appears. In parentheses, we must indicate what we need to pass as a parameter, and that it will be the AttractionID attribute. It will be the same as this AttractionID, which is the value of the database attribute for each iteration. It's quite clear that since the procedure receives an information parameter and returns a result, we can think of it as a function. Now we only have to program the procedure. That is, write the code that will perform the calculation. We'll do that in the next video.